We saw a vector in kind of vector addition, vector dot product, vector cross product, and kind of like through dot product and cross product, we saw the vector essence in particular direction. Okay, so vector is pretty crucial thing. Okay, it looks like some multiplication vector matrix. So these two multiplication, they change complete shape of any mathematics. So I would say these are the most crucial thing in any mathematics calculation. So now when we have seen that from energy direction and energy magnitude, how we add two energy source. If they collide, then how they move in a direction, that how we can estimate the direction. If I estimate that direction, then what is the magnitude of the net new vector? And if I know the direction in Cartesian coordinates, then what would be its angle with its coordinates? So in kind of in coordinate form, we know x, y, z, and what would be its angle. So everything we calculated, and then we saw that the essence of the vector in directions when angles are there. So if angle is available, then in that direction it is called dot product, and it's a scalar, as there is nothing that we can think about a direction. But when we have an angle, and then we can think about the essence of the vector in the perpendicular direction with the angle as a sine theta, and it has the kind of magnitude as the parallelogram with the angle between the two vectors, and maximum is the rectangle or a square whatsoever. And then we saw that it has a direction. If it is a surface, then certainly it will have a direction, and the direction is normal to it. And which side of the plane it is, front side or back side. So that depends upon how we kind of multiply the vertex, how we multiply the vectors. So the direction of vectors matter, like x into y is z, and then minus x into y or x into minus y will be minus z. So that is the direction. So if we reverse the vector, direction would reverse. Okay, so we'll continue with the more example, like if I have a spanner or wrench and it is attached to a bolt, and I place energy on the kind of, if I consider the wrench as a vector, then another vector comes into the picture, and it has a direction with respect to the wrench. And then if it is placed on the wrench, then which side, then since it is kind of perpendicular, so this lead to calculation of the cross product, and then the nut bolt, what we see, that will either go, so it will go in z direction. So either if it goes in kind of positive z direction, then it will come out, and if it goes in negative z direction, then it will go inside. Okay, but the most crucial thing about a vector means there are numerous areas where vectors are, means wherever vectors are, they are highly used, highly important vector or matrix. So now the vector is, among everything, vector is also kind of highly used in lighting calculation, in kind of when we have 3D modeling and we do the lighting calculation. Like I have a light source and I have a surface, then how surface would be illuminated, means how through mathematics I should know that I have to illuminate the surface. So if I have a surface, then there are vertices, like if I have a line Okay, then there is only one vertex, or if I say there are two vertices, but the vector is only one. If I say vector is 2, then their angle is 0. If their angle is 0, then there is no area, so there is no normal vector, so there won't be any lighting. But as soon as we start growing in the angle, then it will form a triangle. Then it will form a parallelogram, and then it will make a rectangle. Okay. So in the lighting calculation, if I have a kind of a shape, or I have a triangle is also a form of half of the parallelogram. So if I have a triangle and I have 3 vectors, then 3 vertices will have a kind of normals. So if they have the normals, so we can calculate the normal. Then if I place a light source, so now through cross product we kind of calculate the normal. Once I calculate the normal, so this is cross product. So once I have the normal of a surface, then light should be aligned to the normal. So their dot product. So first is cross product to get the normal, and then normal to light direction I have to make dot product, so that they should be aligned. The angle between the normal and light source should be 0, so that dot product in a sense cos theta should be 1 maximum. So if light source tilts or surface tilts, means its normal tilts and angle is not 0, then light will not fall perpendicular to the surface and light will not be up to maximum. So those areas we'll see. We'll also see that if I keep the surface constant and if I rotate the light source, we rotate the surface keeping the light source constant, and we rotate the light source keeping the surface constant. It's same, means angle between normal and light source changes, and finally we get the different kind of illumination. We will have a sphere also, where if I revolve the light or revolve the sphere, but one by one vector will come that will be normal to the light, and that region will be kind of illuminated with a good light, and or along slowly if you go the kind of behind in the surface from the light, it will be illuminated less. So the importance of the cross product in calculating the normal of the surface, and then dot product in calculating the alignment of the light with the normal. So it makes a crucial in light calculation, and then we can see the kind of effect of light that is bright to not bright, I would say dim. So that we'll see, and this calculation also works highly kind of useful in calculating the shininess. They should shine, so that it also comes into the dot product and cross product. So that way. Okay, so in the examples, so we discussed the kind of a cross product, and there are 2 vectors, means 2 power strength, and their sine theta is the cross product, and this can be considered as the essence in the perpendicular direction, or many people they discuss as a torque in that direction. So it leads to torque, and then torque can be used to generate energy in perpendicular direction. Okay, so that is the idea behind the scene. So a perpendicular direction can be like, if there is if V is considered as a range vector and force is in this direction, so this is pure energy. And if it is placed here, then it would generate torque in perpendicular direction, the way we are saying in the sine theta. That torque can be used to generate energy in the perpendicular to the surface. Okay, so how much energy it would generate, that is the area. So if both are orthogonal, so this is force and this is the vector, then area is maximum. So maximum energy would come. what is the rule of this? So if I consider this as x, so horizontal is x and this is y, then right hand rule, so x and y, then it would be the kind of the normal to the xy plane, that is z. This is kind of obvious. So here in this case this is x and this is minus y. So force we are applying. So this is minus y. So if this is minus y, then we would probably, this is the direction in which a bolt would go. So probably it would come out, minus n, okay, and minus n means it would go that side, so it would tighten, okay, and okay, so this is minus n, so the n for this would be in other side. So now if I apply energy like this, okay, so if I apply energy like this in this direction, okay, so if this is the F, then we are talking about positive y-axis. In that way, it would come, this will become positive n. Okay, so it will be in this direction. So if this is in this direction, then probably it would open up the bolt. Okay, so that is the concept. Okay, so if I tilt this, okay, so whatever we are showing, if I tilt this, okay, then in that way we will tilt this, okay, if we tilt this like this, okay, so then this would lead to kind of not a rectangle, so area would be lessened, okay, so that way it will come to a parallelogram if we kind of make the diagram pretty neatly and calculate it. So area would decrease. If area would decrease, then net energy, okay, so if I save it, so if area decreases, then net energy would be less in that way. Okay, so we'll come to kind of another example. This is light source and this is a material. Okay, so this is a light source and this is a material. If the material is a line, it's not a surface, there is no meaning of perpendicular normal vector. If there is no normal vector, there is no illumination. So line, generally it is considered as which has zero width. So anyway, for a line, there is no illumination. Okay, what about this? This is a triangle. Okay, and if I see these vectors, this vector and this vector, okay, so their angle, this angle, if I compute 3 and take the average of the normal, probably it would be kind of less than, if I say that most powerful normal is 1, then it would be less than 1. Or if this triangle is tilted 1, can we see this? So its normal is in this direction. So this triangle is rotated 1. So this triangle, Okay, so if it is rotated one, it's normal it is in this direction. Okay, if I say rotated one, then it can be like this. If it is rotated, then this is 0, 0. If it is 0, 0, 0, then we can consider this as kind of minus 1 and then 1 and then some 1, some minus 1. Okay, and then we can consider this as minus 2 and my 1, 0.5. Okay, so it is kind of a rotated one, so it will go beyond that, so it is kind of minus 3. So like this, if that is this way it is rotated. So if that is the case, okay, so then this would be, okay, if that is the case, back to business, okay, so if that is the case, then this would be the normal. If this is the normal and this is the light, how much illumination it would get? Similarly, we have a parallelogram and its normal is pointing in this direction and light is coming from kind of minus x direction. Okay, we rotated the light. Now, light is rotated. Light was coming from minus x direction. Now, light is coming from x and y mixture direction. And normal is here, this way. What would be illumination? Okay, so these are the questions. Now, can we see two things together? This is a very, very big example. Okay, so let's consider this as normal vector. Okay, and let's consider this as light vector. Okay, how? Okay, now let's consider this and this. Okay, to compute normal at these vertices, we are calculating only one. Suppose we are calculating only one normal. Okay, and we'll consider that is for the surface. Okay, so now we'll consider this vector as v1 and this vector as v2. Can we write n equal to v1 cross v2? Okay, now if we cross v1 and v2, that is n equal to magnitude of v1 into magnitude of v2 into sin theta. Okay, into sin theta. So, or probably we have theta somewhere. Okay, so So this is sine theta, where we are talking about this theta. Okay, so this is theta. Okay, so this angle is theta. Okay, so we got the n. So n is kind of proportional to the sine theta, the angle between them. So if theta is 90, then maximum, then it is proportional to strength of vector 1 and vector 2. Okay, so now if I take the n, it is magnitude of V1, magnitude of V2 and sine theta. It is dependent upon all three and we get n. Okay, so direction of the n is perpendicular to this surface of the triangle, what we have drawn here, 0, 0, and this is hypothetical. Now, direction of L, okay, how much energy this surface is getting from the light, okay, I mean how much light it is getting from the light source. So that is the question. Now n we have calculated, so that is calculated as L dot n. L dot n, that would come as magnitude of L multiplied by magnitude of n into cos theta. Okay, so certainly these two are not in the same direction. If they are orthogonal, then there won't be any shining, as it would be kind of cos 90 is 0. But if they are in same direction, then maximum light would come. So first we calculate the normal, and that is the direction of normal, strength of the normal, and then from the light to dot n, and then we calculate what is this quantity. So that much is the light, essence of the light. We talked about essence of the light in the horizontal direction, right? So what is essence of this vector in a horizontal direction? So if horizontal direction is I and this is L, then L cos theta or L dot I. Okay, so L cos theta, if not it is unit vector. L cos theta, if it is not a unit vector, then we will multiply by its strength also. So that is L dot n. So first it dependent upon n, then that is V1 cross V2. Only one we have taken. Someone can calculate all three normals at this triangle, and then it can interpolate the normals as per the distance from these vertices. This is what kind of we see, but we will not make that much complex. So no interpolation, only one we are calculating. So that is normal, and this is the dot product of the normal. Okay, so that is the scenario. So we understood what is the importance of dot and what is importance of cross. Okay, if cross is weak, then normal is weak. Even though it is 90 degree, so normal is weak, maybe probably in a fraction, then this full will be low. If normal is strong, light is strong, and angle is not 0 degree. So so this theta we are talking is, we can say this as theta 2. Okay, so I am talking about this theta. If this come like this, okay, and then certainly it make an angle here. Okay, and this angle will name it as theta 2. Okay, actually we mean theta means theta 2. Okay, if this angle is 0, then L and N means rotated L, not in this. So this is the kind of direction of the light, but in computation we will reverse it. So L dot N cos theta 2 would be maximum. So power of light, power of N, and then their angle, cos theta of their angle. So there it is kind of dependent. So theta give the strength of normal, and theta 2 give the strength of L dot N. So that much it is dependent. Okay, energy absorption and energy generation. Okay, energy absorption and energy generation. If we see the light computation, how light computation works? Light falls on a surface and surface absorbs the light. Now depending on the quality of the surface, it reflects the light. Okay, so if light is white, okay, so what is kind of analogy in light computation? If light is white, R, G and B component is there. It is white, so all three are, we can say all three are 1. Okay, this is Python way. All three are 1. Now this fellow, this Mr. Surface, okay, so Mr. Surface, his color is green. Okay, if its color is green, then it is 0, 1 and 0. Okay, if light falls on this surface, it absorbs all light and reflects only green. Okay, so R and B are gone. If it is red, then it absorbs all the light and it reflects only red. If light doesn't have, if its color is red and incoming light doesn't have red, then it will be black even though incoming light is green and blue. Okay, so if incoming light is green and blue, it would come to some mixture of the light, and color of the surface is red, then it will absorb, but it will try to reflect the red part of it, and there won't be any reflection. So it will appear black, means there is no light. Okay, and if it has only red component, no green and blue, and it is red actually, means no problem. Okay, that is analogy of light, how it does the computation. Okay, energy absorption. How much energy it absorbs? Okay, it absorbs energy as per L dot N. So dot product actually tells the story of energy absorption. How much energy absorption is dependent upon theta 2. If theta 2 is 0, maximum energy absorption happens. How much energy it generates, that is dependent upon V1 cross V2. So that is dependent upon N. How powerful the N is, that much energy it generates. Right now, when we are talking about the light, these two, this surface, this line 1, this line 2, they are not energy vectors. Okay, so generally we take normalize normal. But in this case, can we see this? There is a wrench and okay, so this end there is a bolt and wrench is either tightening it or it is loosening it or untightening. Someone is applying force here. Force is coming as a torque here, means in y direction, the way we talk sin theta. Okay, force is coming as a torque here, like this guy is pulling, it is coming as a torque here. And torque is converted into perpendicular direction as a kind of normal vector. So, how much energy is generated? Now, this is the energy source. If someone is pressing through hand, that is how much energy from a hand is generated. Means that is reaching here. So, certainly it is a cross product of this vector, wrench vector, and cross product of this. Okay, so I think we have placed this somewhere. Yes. Okay, so wrench is V and through hand it is F, then it will be V cross F. Okay, then it is V cross F. Whatever we are talking, V cross F. Okay, so it is V cross F. Now here, this is the same story. So now there is a rule of conversion, like the way we talked, where in which direction normal would point. Now whatever energy we are pushing here, finally that energy is going in the normal that is perpendicular to the surface, and that normal is used, that energy is used in that direction to tighten the bolt or to kind of loosen the bolt. So if I am applying like this, okay, so probably, so we consider this as minus x, this as minus y. So probably this is kind of coming out. Okay, so it is loosening, so it is kind of untightening. Okay, and here, so energy absorption and energy generation. So energy absorption is dot, there is no energy absorption here. And how this works, that we'll see. So I have two GIF images that we'll see. So energy absorption is like when if there is a dot product, then how much energy is absorbed. So how light is aligned to the normal of the surface, that is energy absorption. And how much is N, so that is energy generation. So here energy is generated from this vector, and that energy is used to kind of loosening the bolt. Okay, how energy varies. So how energy actually, what we generate, how energy is generated and how it varies from the direction. So probably we'll execute to GIF file, and that we'll see. Okay, so first we will see this. Okay, so energy is applied in a perpendicular to direction to the wrench, and it is kind of opening the bolt. So the normal, it is perpendicular in the positive direction of the Z, and it is opening the bolt. Okay, so as per the diagram, what we are seeing here, Okay, so the normal vector is probably, okay, so normal vector, what we are saying, okay, it is in perpendicular direction, that is along z axis, positive z axis. So that is a scenario. Okay, so in another, so this is range. So opening the bolt and two vectors are there and it is opening the bolt. I think it is pretty nice enough. Now I have another one. Now how cross products are calculated? So we can see if angle is, okay, so the angle is 90 degree, then okay, so angle is 90 degree between the two vectors red and blue, then their cross product normal strength is maximum, and when it is 0, strength is minimum. So 0 or 180 degree, okay, that is the sin theta. So if it is 90, then we can see the normal strength is growing when angle is growing from 0 to 90. Otherwise, and normal is changing its direction. We can see now it is in negative direction. It is growing but in negative direction. Now, if they coincide, so it is shrinking. We can see, and it shrunk. Now angle is 0, so normal is there is no normal. Now angle is 90 degree, normal is maximum. Now angle will reduce to 180, that is equivalent to 0. No normal. Again normal in other direction. Okay, we call it negative direction. So their normal is going. Now normal would come back to 0. So depend upon blue color and red color vector, that is x and y, and this is how their effective strength would kind of energy that is propagated in the z direction. So one is x and one is y. Then energy is in either z direction or in minus z direction. Okay, so I think it is pretty nice. So we would move on. Okay, so what is lab exercise? We would really see that how kind of if there is a parallelogram and angle is 45 degree, angle is 60 degree, and angle is 90 degree, then it receives more light. Okay, and we have a sphere, we have drawn a sphere. So here vertexes, here the normal are perpendicular direction. So normal are it is towards z axis. So if I can edit it. There is no harm in that. Okay, so what I want to say is that this is x direction and this is y direction, and this is normal to this plane is z direction, that is the normal. Okay, if their angle is 45 degree, okay, if angle is 45 degree, this is 45 degree. Okay, so normal will be perpendicular to the surface, but its strength will be less. Here strength will be more because sin 60 is more. And when it reaches the full kind of rectangle or square, then angle is 90 degree and strength would be maximum as per this calculation. Now first we are calculating the normal. Okay. Now there will be a light source. There will be a light source, and that we'll see, and how we calculate L dot N the way it is. L dot n. So we understood how we calculated the normal, that is V1 into V2 sin theta, and then L dot n, so that we will calculate. Okay, this is a sphere, and a sphere is made up of small triangles. Okay, if it is a sphere and each triangle has a normal, so we can consider that normal is a spread all across perpendicular to the surface of the sphere. So if I have a ball, then everywhere the line coming out of the center of the ball, so to that point, so away from that is the normal. I think that much we can imagine. Okay, so we'll see the concept of what we are saying. Okay, we really have some files. So I have a Python program, and I would say this is okay, this is 45 degree, and this much light we are receiving at 45 degree. Okay, where is my light source? This is light source. Okay, and I can move the light source. I can rotate the light source. If light source is rotating, can we see light is going away and no light? Okay, so let's see if light source. Okay, so light source is rotated. Now I'll rotate the light source again. So light source, so can we think about this situation? What's going on? Okay, so light source is moving. Probably we can see from here. Okay, so light source is moving. So light source, okay, in first position here, light source is throwing the light that is perpendicular to the normal of the surface. Okay, so normal of the surface, or rather I can edit this only. Okay, so if I consider light source, okay, so light source is here, and light source direction is, okay, so light source direction is, light direction is in this direction. If then the normal direction, okay, normal direction is also, it is in same direction. Then theta is kind of 0, means angle is 0. Now light we are revolving around this in 3D. So now light is here, somewhere here in 3D. Okay, so the light normal is like this, and surface normal is in this direction only. They make an angle. Okay, so they make an angle. This angle must be 0. If it is going to be 90 degree, then there is no illumination. This is what we are trying to see. Okay, so if I rotate the light again, and angle is growing between normal and light direction. If it is reaching 90, then there is crossing 90, then there is no light. Okay, that is ambience. Now it will come back then full light. Okay, now normal and light direction, they are along each other. So this much light we are getting. So first thing is how much light we get. So that is the calculation we are doing repeatedly. How much light we get. How much light we get. How much light we get. First is V1 cross V2. That is the normal vector, strength of normal. So here the angle is 45 degree only. So first N is weak. Here angle is 60 degree. And here angle is 90 degree. Okay. So first of all the N is weak, 45 degree. Then L dot N, if both are at in same direction, then maximum light would receive. If L moves, then minimum. What about if this guy moves? This guy is also rotating. And there is no light. It would rotate back. Then there is light. So L dot N works in both fashion. Either light rotates, N is constant, then L dot N varies, or light is constant and N rotates, then again it varies. This is what we are saying. I mean, it can rotate in X direction also. Okay, so now we'll see the change in brightness. Now I'll bring 60 degree. Is it better? Whatever we brought earlier, if there is a difference in brightness, 60 degree, now when we see the 60 degree, then this angle, this sin theta is more. So N is more powerful. Everything is same. N is more powerful. So L dot N is anyway, with all the consequences, it is more powerful. Now we have the light and we are going to rotate the surface only, not the light. So now L dot N is 0. Okay, so it came back and it is rotating again. Okay, so this is the scenario. Okay, no one can stop us rotating the light. Maximum brightness. Okay, so now we can rotate the light, I believe, in X direction also. Same story. Now L dot N is more, it is even more. Okay, so now we'll bring the maximum, that is 90 degree triangle. So that is a plane rather than a triangle, that is a plane. Is it more than what we saw? Certainly it is more. Okay, and we'll rotate and we'll do the same story. So probably we'll shift to sphere. Okay, out of all these three, maximum brightness is that rectangular. We can compare. Okay, so that is the story of L cross and dot. Now I'll bring the sphere. It will put more light into it. This is a sphere. I mean, this is really a sphere. can we see something? The light at the center is maximum. I will bring the light source. Okay, so light at the center is maximum. As we go, light is decreasing, and we cannot see there is a sphere is bigger than this. So what's happening? So L dot n is maximum at the center, and L dot n for this area, it is kind of decreasing. Now, I can bring the light source near to each. Can we see? The sphere is becoming smaller. A sphere is actually this big. But if light is near, then the angle is decreasing as per the calculation. Okay? I'll bring it again. Okay, I'll move the light near. Okay, light went inside that. So see, if a light comes far, then that is the maximum illumination we can see. Light goes near, then that radius would start decreasing. See? I can rotate the light. See? Okay, so this is solar eclipse or lunar eclipse. Oh my God, this much only, but it is actually bigger. Okay, so what is the concept we are trying to show here? Okay, if light is not coming as a kind of from infinite source, the way we are drawing, light is coming from infinite source. Okay, so light is not coming from infinite source. Let's consider this. And light is coming from a point. Okay, if light is coming from a point, now okay, if light is coming, then the region which is at the perpendicular to the where normal nearer to the light, I would say, that receives more light because L dot n is 0, means cos theta 2 is 0, so maximum. What about this light source? Light is going to these areas. Okay, for these areas, normal is this. For these areas, normal is this, so there is an angle. For this reason, normal is in the same direction. Okay, for these areas, normal is in the same direction. Okay, angle is 0. For this area, there is an angle. There is an angle. So, now, if I take the light nearer, here, okay, if it is here, then we saw this angle. If it is here, then this angle would grow. If it is here, then angle we saw. Now if it is here, then we'll draw the angle again. Can we see this angle grew? Now this becomes this angle. This angle is more. Okay, if light source moves, then each point in the sphere, the angle is different. So more angle, light would decrease. Okay. Now light is increasing because light source is coming far. It is going far. then many reason outside they are getting the theta less. Okay, if it is going near, then theta is more and illumination is decreasing. Okay, now I can rotate the light. Can we see? That region of the sphere is illuminated because they are finding their normal and light source angle being less. So these reason the angle become too much. I am not rotating the sphere, I am rotating only the light. Same story if I rotate across X. Okay, I can rotate the sphere. Okay, probably I can try again. There is no light. Okay, so light source is constant. This is what we are trying, and we will rotate. Okay. Okay, so I'll bring it back. Actually, I am rotating light, but actually locally there is no light. So I brought the light. It is getting dark. It's night. Okay, so now this is light source, and we can rotate the light source. Okay, now I'll try to rotate the sphere. Okay, I am rotating the sphere, but there is no change. Okay, if there is no change, means something is coming, some point is coming, it's a sphere, it's a round. So it is showing no change. Okay, I can move the sphere. Certainly there will be change. Can we see the red spot is moving? Okay, and right. Red spot is on right direction. This is red spot. Okay. Red spot is coming in left direction. It is very clear. So this is as per and the darkness on the right side is growing, whereas here darkness on the left side would grow. It is growing and this is brighter. So everything is happening the way we are thinking. Okay, I believe we can rotate as per the global axis also. Now, the sphere and light both are rotating. We are rotating full global axis. We can clearly see wherever the light falls normal, light direction and normal to the sphere, from the sphere are in the same direction. Brightness is maximum. Okay, we'll try next direction. Okay, I think it's enough to explain the light, how it goes from maximum to minimum. So, okay, if I bring the light near, to the sphere, then so this much is the reality. Okay, this is how it is. So we are rotating both. So it is near, so circle is. Now if it comes out, circle is bigger. Okay, so I'll try to get it near so that circle will be smaller. It is getting smaller, and if it is big, going. Okay, I can bring it more far, so this much it can illuminate. Okay, so I think it is big enough to show. So we started from a vector addition, two vector combines, and how it result in resultant vector, and then combining two vector, we kind of understood from like two vector coming from two direction, two energy source coming from two direction, and they are resulting into one vector that is going in direction. Then we can simply add it like this. Energy model of the vector, we saw energy vector is nothing but energy which has a direction and which has a strength. This is more powerful, this is kind of feeble. Okay, if vector V2 is there, V1 is there, if they merge, then they will become V, and V1 is this and V2 is this, the net vector will be like this. Okay, if energy source is moving in this direction, a person who is standing on x-axis or I, how much energy he should feel that he is receiving the energy, how much? Okay, so that we saw. So that would be cos theta, and how much someone should feel standing on the y-axis, that is sin theta. And same way, how much work is done when the workload has to move only in x direction, that is cos theta, that is scalar product. How much work is done, it has to move in vertical direction, so that is sin theta, and that is vector product. Vector product can be understood through area, the way integration in calculus we understand through area. So bigger area means vector product is powerful, smaller area vector product is less, and the direction of the vector product is perpendicular to the area that we saw. So if it is moving like this, he is generating the torque, and torque can be converted to the energy that is perpendicular to the surface that we saw. Okay, this is the kind of the way it changes. Like wrench, this is the direction of wrench, and force we applied, then it would generate a torque, and torque energy can be converted in the normal to it. Okay, nicely we saw that wrench is generating a torque, and that torque is energy generated in perpendicular, so it would kind of loosen the strain. If it goes, it would otherwise, then it will tighten the bolt. How it moves, how we saw, like how the normal perpendicular to it changes. Okay, so in lab exercise we saw if angle is less, then normal is weak. If an angle is more, normal is more, and angle is maximum, normal is maximum, and it changes. If normal is maximum, then L dot N is maximum. So energy light absorption, light absorbed from the light source is maximum here. It is less here. And now when we came to sphere, we saw that a sphere is not a flat. So light falling here is at the 0 degree with the normal, and light falling here, if I keep light perpendicular to this location, then light and normal here are in the same direction. So maximum light is decreasing, and after this to some distance there is no light. Okay, if I bring the light source near, then these angles are growing with the light source, and it becomes smaller and smaller. Okay, so we'll see the light analogy kind of how it look in the practical sense. Okay, so it looks like this, and then we'll make it near. Now we can say it is kind of shrinking. So this is the scenario. Okay. Now if I take kind of print this screen and we bring it somewhere, and so like I open a new, then I would paste it. Okay, so this is the scenario what we are seeing. So if I the light direction, then this is the light source. So for this vertex, this is the light direction. Okay, I mean this is visible. Okay, and the normal for this vector or lid is also in the direction of the light source only. Okay, so we can see the glow is maximum. Okay, and what about this area? So normal would be somewhere. Normal would be somewhere here, and light direction, what we keep on talking, so that would be in this direction. So we can clearly see there is angle. Means it would be even more. So the light reaching in this direction is less, whereas light reaching in the front where the angle is 0 is more. So same would be for kind of other location. So if I see here, then vertex normal would be like this, and if I see light direction, then it would be like this. So if it is crossing 90 degree, then there won't be any lighting. So okay, so the idea is light at the center is maximum, and since angle is growing, light at these areas, okay, are less. Light as, okay, and light in these areas, since angle is growing, even less, or it is dark. So if I move back the light, okay, so if I move back the light, then we see the changes. So wherever light is going, it's normal, and okay, so this is exactly in the kind of direction of the light. Same thing. Now this is completely in the direction of the light, where these are making angle and these are making angle more than 90 degrees. So this is how it is. Okay, so
much.